here we have some indefinite integral, x squared over x times sine x plus cosine x quantity squared. So first, I'm curious to find out what's the derivative of this bit. Sine x plus cosine x. What's its derivative? Right? Differentiate x gives me 1. 1 times sine x. Keep x, differentiate sine x. Cosine x. Differentiate cosine x. Negative sine x. So sine x, negative sine x, cosine x. Okay. But I don't have exactly x cosine x on the top. So I'll just do this. I'll just multiply x cosine x and divide by the same thing. So first, let me copy down x sine x plus cosine x quantity squared. Like I said, I'm going to divide the same thing. X cosine x. And copy down x squared. Right? But here, x squared and x, they can just simplify. Right, down to just x. So, dx. So I have two bits, right? This bit, that bit. So that automatically motivates me to use different integrate by parts. Right? So which one is u, which one's dv? Right? Since I already know this bit is the derivative of this bit, so it's easy for me to find antiderivative of this bit. So this should be dv, this should be u. Right? U x over cosine x dv x cosine x x sine x plus cosine x dx. And so du, what's du? Du should be easy. Cosine square, differentiate x, that's 1. 1 times cosine x minus keep x, differentiate cosine x, negative sine x, negative, positive x sine x dx. And so therefore, the antiderivative of this thing is what? Like I said, top is, so the bottom, this bit is t squared. T squared. The top is just dt, right? Because it's derivative. So when you have dt over t squared, antiderivative is immediately negative 1 over t. Right? T is this bit. Because if you differentiate this, so the whole thing to the power of negative 1. Negative 1 times negative 1, positive 1. Negative 1 becomes power of negative 2. Right, so the bottom power of 2. The whole thing. To differentiate this bit gives me that. So exactly this is the v. Right? So therefore, uv minus, right, previously I have u dv, now it's v du in here. So what's v du? Top is this bit, bottom is the same bit, so they just cancel out. I only have 1 over cosine square, negative, so dx. Right, so negative, negative, positive. Right? So, but this bit is what? This bit is easy. This antiderivative tangent x, because tangent x derivative is 1 over cosine x squared, right? Remember, tangent x is just sine over cosine. So uv x over cosine x, x sine x plus cosine x. Right. Like I said, plus tangent x. Right? Tangent x sine x or cosine x plus c. Right? But first, let me simplify. Cosine x, common denominator, is still the same thing, except now I have negative x to begin with, and this should be multiplied by this bit. So sine x multiplied by x sine x plus cosine x, then plus c later. And what is that? Right? That I can just distribute. So x sine x squared plus sine x cosine x, right? Cosine x, x sine x plus cosine x. And what is that? That x factored out, negative 1 plus sine x squared. Okay. What is that? 1 minus sine x squared is cosine squared. Now it's negative plus, so it's negative cosine squared. And not only that, here I have common factor cosine x. So cosine x, cosine squared becomes just cosine. Now let's double check our answer. And of course, don't forget plus c in the end. So differentiate this thing. So x sine x plus cosine x, quantity squared. Differentiate the top, negative cosine x, negative sine x, plus sine x become plus cosine x. Right? That's the multiply the bottom. Cosine x minus copy down the top, negative x cosine x plus sine x. Differentiate the bottom. Sine x plus x times cosine x minus sine x. And so this is sine x cosine x. What is that? Negative, positive gone. So x squared sine squared. Then x sine x cosine x. Okay, here, sine x, negative sine x. Okay, so there is a negative, negative. Here's a positive, positive. This times that. Positive x squared times cosine square. There is a positive, negative, negative this times that. Negative x times sine cosine. Okay, so negative, positive, right? X squared, common factor, sine squared plus cosine squared, 1. So x squared times 1, and we're good.